Alright guys, here's the answer key for Learning Target 1, 2, 3 in your 1FA3 review guide. These are problems you did on Edge Elastic, and you're going to get to see the answers to those problems here. If you need to skip around to a different question, like if you're comfortable with number 4 and want to see 5 or 6, or any of these other problems on 1, 2, 3, feel free to skip forward in this video. But we're going to go ahead and get started, guys. So this question asks us to calculate the formula mass of these 3 compounds, and we're going to go ahead and do that. So the first thing we have to do is list our elements. Remember, every capital letter tells us an element. So we've got carbon, hydrogen, and oxygen in this compound. And then we're going to look up the masses of those compounds on the periodic table. When we do that, carbon is 12.01. Hydrogen, so way over here, is 1.008. And oxygen, our best friend, we know is 16.00. And now we're going to multiply by the subscripts. There's a 2 on carbon, so we multiply there. 12.01 times 2 is 24.02. Hydrogen, there's a 6, so times 6. 1.008 is going to give us times 6 equals 6.048. And then finally, oxygen, when there's no subscript, that means 1. 16 times 1 is 16. And then we have to add those 3 values together. So in the calculator, we're going to take our mass of hydrogen and add it to the mass of our carbons plus the mass of oxygen. And we get a total mass of 46.068 grams per mole. Right, so there's our answer, 46.068 grams per mole. We're going to do the same thing for letter B, barium phosphate this time. We're going to list our elements. We've got barium, phosphorus, and oxygen. Remember every capital letter. Barium, we look up the mass on the periodic table. It's way down here, 137.33. Phosphorus is over here, 30.97. And oxygen, our good friend, is 16. Now we're going to multiply by the subscripts in this formula. Barium has a 3 attached to it, so we multiply this number by 3. 137.33 times 3 gives us 411.99. Phosphorus has a 1 attached to it because there's no subscript, but it's inside parentheses, so we also have to multiply by the number outside the parentheses. So times 1 times 3. 30.97 times 1 times 3 gives us 92.91. Oxygen has a 4 on it, so we multiply by 4, but we also have to multiply by the 3 outside of the parentheses. So 16 times 4 times 3 gives us 192.00. And we're going to add all that up and get an answer. So we're going to type 411.99 plus 92.91 plus 192. And we get 696.9 grams per mole. And there's our final answer. We've got one more question to do here, letter C, aluminum acetate. And this one has 4 elements this time. So we've got aluminum, Al, carbon, hydrogen, and oxygen. Right? Aluminum on the periodic table is 26.98 times the 1 subscript on aluminum equals 26.98. Carbon, there's 12.01 is the mass, right there, times the subscript on carbon, 2, times the subscript outside of the parentheses, 3. So 12.01 times 2 times 3 gives us 72.06. Hydrogen on the periodic table, 1.008, times the subscript 3 on the hydrogen times the 3 outside of the hydrogen, 1.008 times 3 times 3 gives us 9.072. And finally, we have oxygen, 16, times the subscript, on oxygen, which is 2, times the subscript outside of the parentheses, which is 3. 16 times 2 times 3 gives us 96. And now we're going to add all that together. So in our calculator, 26.98 plus 72.06 plus 9.072 plus 96. Messed up somewhere. 26.98 plus 72.06 plus 9.072 plus 96. And we get 204.112 grams per mole. There's our answer for aluminum acetate. Question number 5, the next question, asks us to determine the mass of 2.5 moles of calcium carbonate. And they give us the formula for calcium carbonate. So we start by writing down what they give us, 2.50 moles of CaCO3. Set up our conversion times in a line. We want to get rid of moles, so that means we put it on bottom. We want to find mass in grams, that goes on top. This fraction, these numbers come from this fraction right here. There's no number with moles, so that means 1. And our molar mass, right there, is 100.09. Moles will cancel. And we get 2.50 times 100.09. And that means we get 250.225 grams of calcium carbonate. We should round that answer to 3 significant figures. So 250 with a decimal point. The next question is very similar. How many moles? This time we're finding moles when we have grams. So we start by writing down our mass. And we multiply by a conversion factor. The unit we want to find goes on top, moles. The unit we want to get rid of goes on bottom. And our formula mass gives us those numbers to put in the fraction. 1 with mole, 53.491. With aluminum chloride, I'm going to put this in parentheses, cross off grams, and then multiply this just like it shows up here. 75.0 times parentheses 1 divided by 53.491, close parentheses, equals 1.40 moles. So that's our answer. And finally, the last question in this learning target, determine the number of moles in 80 gram sample of carbon dioxide. And we're given the formula mass of carbon dioxide. So we start by writing down our provided value in the problem, 80 grams. And we want to set up a conversion factor where we find moles. Moles goes on top. We want to get rid of those grams, so they go on bottom. And now we have values to put in, 44.01 grams per 1 mole. That means 1 goes with mole. And 44.01 goes with grams. Grams cancel out. Make sure we use parentheses. And we'll type it just like it appears. 80.0 times parentheses 1 divided by 44.01, close parentheses, equals 1.82 moles of CO2. There we go. All done.